Hello and welcome. So in this video we are going to continue from where we left off in the previous video, and we're going to see how to get started with running a PySpark notebook, Jupyter notebook with PySpark in it on our Google Cloud Dataproc Hadoop cluster. So the first step is to create the Hadoop cluster. So for that, go on to Google Cloud and click on the navigation menu, scroll over to Dataproc and click on clusters, and click on create cluster. So we're going to use cluster on compute engine. So click that, and I'm going to go a little bit fast with this, but if you want to see more details on how to create a cluster, please check out my previous video. So here we are going to choose all the default options on the main page. We're going to enable component gateway. We're going to enable Jupyter notebook. In configure nodes, we are going to again choose the defaults to the extent possible, and keep going. Customize cluster, we will uncheck the configure instances to have only internal IP, because we want external IP addresses to be able to connect to these instances. And we're going to use a storage bucket that I had used in my previous discussion. So I'm just going to use that here, and that is called, okay. So RS my new bucket 123, I'm just using that, continuing from last time. And finally, manage security. I'm going to enable cloud platform scope for this cluster, because I would like to make sure that this Dataproc Hadoop cluster is able to connect to my Google Cloud storage, where I'm going to be storing files. So let me just quickly open the storage as well. So if you scroll to the navigation menu and scroll down to cloud storage and click on buckets. You can either create a new bucket if you don't have one, or if, like me, if you already have a bucket, you can just open that. So this is the bucket where the data will be saved. Just to let you know how it is like from scratch, I'm just going to delete all the existing folders in my bucket, and I'll start from from scratch, from completely blank slate. And once all the existing folders are deleted, I mean, you don't have to do this. If you already have these folders, you should probably keep them. I'm just deleting it to show you what an empty bucket looks like, and how things unfold in that empty bucket as you go along. I'm going to create a folder called data within this bucket, which is going to be the place where we will store our data, which we are going to download from the web. So just so you know, we are going to download the data from NYC taxi data website, TLC trip record. So here we are going to go to data, and TLC trip record data 2019 January and February. Okay, so those are the two data sets that we're going to import. But before that, let's get started with our configuration. Let's continue. So manage security, enable cloud platform access, and then go ahead and hit create. And this takes a little bit of time, so it might take 3 or 4 minutes. Okay, so some time has elapsed, and now I have my cluster running. And how can I tell? Because there's a green check mark here and it says it is running. So in your case, it might take a little bit long. So just hit pause over here and then just wait for your cluster to get started. And once it has gotten started, you can continue from here. So just click this cluster link over here, the blue link, and you will be able to enter a screen where you can go to web interfaces and scroll down a little bit and hit JupyterLab. And that brings us to our Jupyter notebook on the cloud that is connected to our Hadoop Dataproc Hadoop cluster. Okay, so here it is. Still waiting for it to fire up. Okay, so here we are. So you can click on a Python notebook or an R notebook or a PySpark notebook or a Scala notebook. We are just going to focus on PySpark for now. Very quick reason why is because we are looking at big data, and PySpark is ideally suited for big data because of the Spark framework. that treats data that is located on multiple computers as if it is one single data file. So we're going to use that. If you have smaller data files, you can use R or Python, but we are going to use PySpark for now. So I'm just going to double click. Okay, and it has created a file. So I'm just going to give it a new name. I'm going to say my first PySpark. Okay, my first PySpark. Just give it a name like that. You can give it any name you want. And I just want to show you where this file is getting saved. So it is getting saved in our bucket that we specified. So in this bucket, if you go back one step higher, you have a bunch of other files that have been created when you linked up my new bucket to this Dataproc, that's when that happened. And so within that, if you click on notebooks and go to Jupyter, you'll see the notebook you just saved, my first PySpark.ipynb. So that is a notebook there. Now, just a quick pointer. When you are done with your analysis for today, for your session, you can go ahead and terminate or delete your cluster. Don't do it now, but at the end you can delete or terminate your cluster, and you can save money. Now, if you delete your cluster, where is the data getting saved? So because we specified this bucket, the data gets saved in this bucket, and so does the code. The code is getting saved here, and the data is getting saved in the data folder. Okay, so we don't have the data yet. I'm going to upload that now. So you can, at the end of the session, you can go ahead and delete your Hadoop cluster. Okay, so now let's get some data into this. So for that, I need access to the terminal of the master computer of this Hadoop cluster. So for that, go back to cluster details and just click on the cluster link again and go to VM instances. Earlier we went to web interfaces, now go to VM instances. And you can see that this is a 2-machine Hadoop cluster with a master computer -m and a worker node -w-0 and a worker node, another worker node w-1. So we can access the master computer by clicking the SSH button here like this. And then that pulls up a terminal interface like this for us, where we can use this to import data. So I'm just going to log into it. And you can see that there is a user interface. So what we're going to do now is we're going to go to our NYC taxi dataset website, and we're going to January 2019 and right click and copy the link address. And we're going to come back here and say wget. Wget is a Linux command that says, okay, get me a URL data. And then I'm going to say Control V to paste that URL that I just copied. You can see that it's not a CSV file, it's a Parquet file, which is an optimized format for big data. And I'm going to hit enter, and that will quickly download that data set in the cloud. So I'm going to say ls -l, and you can see that that data has been downloaded in the current folder. I'm now going to go to the February dataset, copy link address, and I'm going to paste that again here, wget, control V, and hit enter. And the second file is also getting downloaded, ls -l, and now you have 2 files here, or I can just say ls. And you have 2 files here, trip data 2019-1, trip data 2019-2, both have the Parquet data format. So now what we're going to do is we have gotten these 2 data files into our Hadoop cloud, Hadoop Dataproc machine, VM instance, VM cluster actually. But it's an expensive place to store data and analyze data. You can analyze this data right here, okay, with a tool called Pig and Hive and so on. You can do that, but that'll mean that you're storing your data in your Hadoop cluster, which can get expensive. It's cheaper to store the data on your storage bucket on Google Storage. So for that, now we're going to transfer the data from here into our Google storage bucket, specifically into the subfolder called data, which we had created a little while ago. Say gsutil cp yellow star, and if I say yellow star, it's going to choose all files starting with the letters yellow, and then that's going to be both these files for now. Those are the only 2 files. And so yellow star to gs:// And I'm going to go here and copy this, this pathway here, and paste it like this, and then hit enter. So basically what this does is it makes use of the GSUtil set of utilities, and then within that one of the functions is called CP or copy. And then what that lets you do is it lets you specify a bunch of files that you can copy from the current location into Google storage. And where within Google storage? So that is this location here. You have to specify your bucket and any subfolders within that bucket. So the file has been copied, and now I can go to the bucket and check that it has indeed been copied. So I go to the bucket, hit refresh inside my data folder, and sure enough, there are these two files which I just now copied from my Hadoop cluster onto my Google storage. So having copied these two here, now I am ready to actually go to my PySpark notebook and import these two files. So to do that, I'm going to use a command that looks like this. So I'm going to define a data frame called df1, and into that I'm going to save the contents of this Google storage bucket, rs my new bucket 123/data. I'm going to store that using a function called spark.read.parquet. So basically it says okay, use the Spark library, within that the read function, within that the Parquet method, Parquet, that basically tells Spark that okay, the files that we're trying to read are of the Parquet format. And once that is done, obviously in your case you have to put your bucket name here, so just be careful about that. You can press shift and enter. Press shift enter and you'll see a star sign that basically tells you that the data ingestion is happening. It'll take a little bit of time, and so just give it some time. And now you can see that the ingestion is over because the star sign is over, and you see the number 1 here. That means this command has been executed. Next, you can take a look at the contents of your data frame. You can say show 10 or show 5. Show me the top 5 rows in this data frame. So you can just ask it to do that, and it'll show you the top 5 records. I'm just going to make this a little bit bigger so you can see everything. So you can see the top 5 records are there. It has helpfully separated out the column names and the data themselves. Then you can continue to do some other analysis. So now what I'm doing is I'm creating a new data frame based on the first one, where I'm selecting only 3 columns: the passenger count, trip distance, and tip amount, which is passenger count, trip distance, and tip amount. So those are 3 columns. I'm just selecting them and saving them into a new data frame called df2, and I'm asking it to count the number of records, or maybe I'll just show df2. So you can see there are 5 records from df2, and I can see how many records are there in total in df2. df2.count. Let's see how many records are there, and then I can say I want to remove duplicates from df2. I can say df3 equals df2 remove drop duplicates, and I can say df3.count. So after dropping duplicates, how many are there? So right now there are 14 million records. So there are 14 million records. So that means there were 14 million taxi trips taken in the months of January and February put together of 2019. I'm going to drop duplicates, and now having dropped duplicates, since we are only taking passenger count, trip distance, and tip amount, there could be a lot of duplicates here. So after dropping them, the number of records reduces to 800,000, which is also quite a lot. So you can see this is not a small data set. 14 million records are not going to fit in your Excel spreadsheet, or if you're going to open it on your local computer, it's going to take a really long time. So we need something like the PySpark tools that we're using for this. So next, we want to filter D3 to obtain only those records where the number of passengers is 1. That means all trips where there's only 1 passenger, and do a count of this. Okay, so we want to do a count of this. So we want to, the way we do this is through method chaining. So basically you can say df3 dot passenger count double equals 1. So double equals means you're comparing the passenger count and saying whether the passenger count is the same thing as a number 1 in the passenger count field, whether the number is number 1. And then if that is the case, perform a filter according to that criterion on the df3 data frame and do a count of the results. Okay, so shift enter. So if you know SQL, you'll see there's a lot of similarity between SQL and what we are trying to do here. So these are all just two different ways of getting to the same result. If you have a data frame, if you're manipulating it through pandas or PySpark or R or anything, that is quite similar to the way, what you would do in a SQL database. Okay, so there are 332,927 trips where from the truncated list from this 800,000 where there was only one passenger. Now you can do some summary statistics. You can say df3 describe show, and it'll show you a bunch of summary statistics relating to the df3 table. So count, mean, standard deviation, min, max. If you want, you can do summary statistics for a particular passenger, not for just the entire table. If you just don't specify any field within describe, it will give you summary statistics for the entire table. If you specify a particular field, it gives you summary statistics for that particular column. So once you're done with your analysis, I'm just trying to show you the full life cycle of an analysis in a short form. So once you've done your analysis, you can save your new data frame as a CSV file, for example, within storage. And the way you do that is df3.write.save, and then you specify a path. The path is going to be, again, I have to specify my bucket path here, so I'm just going to paste that here. So instead of data, I could make it as data2, just so that you store it in a different location, and then df3 write save, etc., blah blah, and then format specify CSV header equals true. When you say header equals true, it treats the first row as the header row. That means all the information contained in the first row is treated as column names rather than as data. And so I'm going to press shift enter, and it is saving that. And once it is saved fully, I'm going to go to my data storage bucket and then check if it has indeed saved it there, and then I'm going to download it and just take a look at it. So the operation is over. Now I can go to my bucket, I can go up one step and then go to data2, which has been automatically created for us. The folder has been created. Within that I have a quote-unquote file called trips2, but it looks like a folder, and this is a common pattern that you will see in a lot of big data environments. Namely, you will see large data set get truncated into lots of small data sets and saved with machine generated file names, but then it has a higher level folder name like this. Like we wanted to save it as trips2.csv, so it created a folder instead of a file called trips2.csv, and within that it just created files with chunks of data that together constitute the data that we are looking for. So you can actually, I'm just going to download this one particular file just to kind of see what it looks like. So I'm downloading it to my local machine, and here it is. So you can see that it does contain passenger count, and then trip distance, and then tip amount. So it does contain that. Okay, so that gives us some confidence that we have successfully transferred our dataset. So that's it for now. So I hope you found this useful. This what we just saw is a complete life cycle of how you can import some dataset from the cloud, transform it, and save a transformed subset of that data into your bucket, and then from there you can download it to your local machine or do whatever else you want with it. So one last thing before you leave, I just want to be careful to delete all unnecessary so if you don't want this data after you're done with your analysis, you should probably delete it. I'm just going to select it and then hit delete. So this bucket, this extra cautionary feature has been kept here so that you don't accidentally delete any data. So I'm going to hit delete, and so that is being deleted, and then I go to my bucket once again and go to data. Data 2 was deleted. Now data, I'm going to delete that as well. Hit delete. Yes. Okay, because I decided now that I don't need this, but if you need it for, let's say, for an extended, for let's say a couple of weeks or something, then you can perfectly keep the data in your bucket, because it's not that expensive to keep it there. But definitely at the end of your session, you want to save your Spark notebook, close it, and then you want to delete your cluster. So go to your cluster and actually go back to your cluster details, select the cluster and hit delete, because otherwise it can just add up. If you're done with your analysis, just delete the cluster, while you can be sure that the data that you have saved will be available in your bucket. So I deleted, the data will be deleted, but the code will be saved in your bucket. So this code is not going anywhere. It will be there for you the next time as well. So you don't have to worry that you're losing your work. So I'm just going to go here and confirm my deletion. And just wait for it to actually complete deleting before you sign out, because otherwise it might just stop midway, and then later on it'll tell you, oh, I did not delete it, you didn't tell me to delete it, and then you'll end up with a big bill, and then you have to be on the chat with the customer support staff trying to get a refund. So to avoid that, just make sure that this deletion completely happens. Okay, so the deletion is complete, and now you're free to sign out. So that's it for now. I hope you enjoyed this video. Thanks for watching, and have a wonderful time.